Okay, so this briefing video is going to give you some background, some information about what you're doing for your paracetamol synthesis experiment. So what you're going to be doing in this experiment is you're going to be starting with 4-aminophenol. You're going to be reacting it with acetic anhydride, and these two chemicals are going to come together, where the amine and the anhydride are going to come together, and they're going to form a new amide bond, and this will give you paracetamol with acetic acid as a byproduct. Now, by doing this experiment, you're going to be learning how to perform standard techniques that we use to synthesize organic molecules and drug molecules, most of which are organic. The key skills you're going to be doing are you're going to be sort of learning how to heat a reaction together under a technique that we call reflux. So this amide bond formation needs some heat, and I'll explain a little bit later why we need to heat certain reactions. You're going to be using vacuum filtration, which is a form of filtration, but it's a much more quicker and more commonly used than a simple sort of gravity filtration. And then you're going to be using IR spectroscopy again, this time to confirm that you've got the correct structure of paracetamol, but also that your sample is pure, but it's also dry as well. So in addition to this video, there are more Prelab videos that show you how to perform these techniques, how to set up and run a reaction under reflux, how to perform a vacuum filtration. Okay, so do watch these videos because they will ensure that you perform the techniques correctly. You'll be able to work through the experiment much quicker. You'll get things will work a lot better for your experiment, and you'll get a higher yield and better results as a result of watching these videos. Okay, now what we're going to do is explain to you why do we heat or cool reactions. Okay, now the default way of doing a chemical reaction, the easiest thing to do is to mix and stir the chemicals together at room temperatures, and there's a lot of experiments that will just simply work really well. But by doing this, they work absolutely fine. We form new bonds, we break the bonds that we desired, and we get the molecules that we want to make. But there are some instances where that doesn't happen at room temperature. If, for example, we have a reaction or a chemical process that's slow, okay, then what we want to do is we want to heat the reaction, and by heating the reaction, what we're doing is we're increasing the rate of the reaction. We have more molecules we're giving the molecules greater energy, so when they collide together, they're more likely to have enough energy to get over the barrier to forming a new bond. Okay, so that's the key reason why we heat reactions, and that's why we're asking you to heat a reaction using a technique called reflux to make paracetamol. Sometimes, though, we cool reactions down, and the reason why we cool reactions down is because the reactions at room temperature are much too vigorous. Okay, they can start they're usually exothermic, so they start generating their own heat, and as they're generating their own heat, they get faster and faster, and sometimes you get a runaway reaction, a reaction that's out of control, and that can obviously be quite dangerous. So what we do to control that is we try and decrease the rate of the reaction. So we cool the reaction down. It means that we can make sure that the reaction's happening in a much more slow sort of process, and then when an exotherm is produced, the cooling will cool the reaction down and stop the reaction from rising too rapidly in temperature. And so this is the basics of how we sort of set up and run a reflux reaction. Okay, so what you have is a round bottom flask. Okay, and in there you'll have your reagents, your aminophenol, your acetic anhydride, and you'll have water in here as well. And the role of water is it's a solvent. It sort of mixes all the reagents together. And then what you'll do is you'll heat the reaction. You'll heat the reaction to its boiling point. And the thing that's going to boil will be the water, because that's what you've got most of in here. That's the solvent. The most of the liquid that you have in this reaction will be the water. So in this case, the temperature of the reaction will go to 100 degrees. So even if you set your hot plate to a temperature much higher than 100 degrees, inside the reaction flask, the reaction can never go above 100 because as soon as the reaction reaches 100, the water starts to boil. And so for this reason, you place a condenser on the top of the flask because what the condenser will do is it will take those water vapors. As it goes up, it will stop the vapors from evaporating out of the flask and making your reaction evaporate to dryness. We don't want to do that. We want to make sure we keep all the water that we have. We've got the same concentration in our reaction. So the water vapors come up, they cool down and condense in the condenser, and they drip back down. And so what we know is that when we have a reflux reaction, is when you start seeing that boiling and condensing. So you see like a drip, drip, drip of the solvent going back into the reaction flask. That's when we say a reaction is at reflux. Okay, so the temperature of a reaction at reflux is always whatever the boiling point of the solvent is. In this case, it'll be water, so it's 100 degrees. Finally, just some tips to make sure that you set up the reflux correctly and it all works well, because obviously when you're heating a reaction, it can be quite dangerous as well. Okay, so firstly, you have different size condensers and flasks, okay, and they have joints that connect them together. You need to make sure that you're using the correct joint sizes so they match and there's no gaps between the condenser and the flask, because otherwise then the water will just escape out of the side. You need to make sure you clamp the apparatus correctly. Okay, so this is the neck of the round bottom flask. Okay, this is so just in case your reaction is in a dangerous place, we need to quickly get it off the heat. We need to be able to lift it off the hot plate, okay, and off the heat source. Okay, so if it's clamped around the neck of the flask, we can lift the whole apparatus up just by lifting the neck, or the clamp that's around the neck of the flask. If you clamp around the condenser but not the flask, then the flask will just simply fall off the bottom due to gravity. And the other thing as well is to make sure there's no water leaks as well that's going through your tubing. So in fact, always make sure you check that your water is running through your condenser before you start heating the reaction. And in fact, it's good practice to check your water running through your condenser, not above, with your condenser not on above your hot plate, okay? Because what you don't want is your tubing to leak and then for it to leak onto your electrical hot plate. That can be quite dangerous. So take your condenser off, turn on the water, check it's all fine. If your water is all fine, then and there's no leaks, then you can place it back onto the reflux apparatus and you can start heating your reaction. If there's leaks, then we need to try and find some other tubing or some cable ties to make sure there's no leaks in your condenser. Okay, so those are the tips just to make sure, key tips to make sure you set up and run your reflux correctly and safely. The last thing is, after you have done your reaction, you need to cool it back down to room temperature. And what's supposed to happen is the paracetamol is supposed to precipitate out of the water because it's soluble when it's hot, but it's not very soluble when it's cold. Now sometimes this doesn't happen when you cool the reaction down, but there's a trick that you can do to help the crystals form. What you can do is when you cool the reaction down and it's at room temperature, you can cool it further in ice and then take a glass rod and then scratch the inside of your round bottom flask very gently, not too hard so you break the glass, but just a gentle scratching against the glass. And what that helps to do is it helps to form the crystals forming. Okay, so if you don't get any crystals forming when you cool the reaction down, use this scratching of the glass rod technique and you should be able to get some paracetamol precipitating out. Okay, so that's the sort of the briefing for the paracetamol experiment.